Assalamualaikum and very good morning. So today we would like to learn about integration by parts. So how this is the steps to solve the integration by parts. The first one, you need to identify U and dv. Next, you need to find du and v. And the third one is you need to use the formula integration u dv is equal to uv minus integrate of v du. So this is how to find U and dv. So you are using the Lyautey. So you need to remember Lyautey. What is this? What is this? Is this a logarithmic, inverse, algebra, trigonometric, and exponents? Note, choose the function which comes first as U and the second function as dv. So this is an example from YouTube how to solve the integration by parts.
Hey everybody, this is Paul. In this tutorial I'm going to be doing an example of integration by parts. So integration by parts is just another way that we can use to evaluate an integral. And this method is typically taught around the beginning of a second semester calculus course. So basically this is the general form of integration by parts. And if you don't know what this means, don't worry about it. I'll kind of be translating what this means through an example here. So for our example, what we're going to do is we're going to look at the integral of x times e to the x with respect to x. And we want to basically use integration by parts to do this. So what we have to do is we have to label part of this u, and the other part of it we need to label dv. So usually what we want to do is we want to pick the part that will kind of turn into a constant if we take the derivative enough times for our u. So if we take the derivative of x with respect to x, it will turn into the constant 1. So we'll just go ahead and pick that for our u. We'll just put that over here. U, we decide, is going to be x. And since we chose x to be our u, that means the rest of this stuff has to be the dv. So dv is equal to e to the x dx. So now that we've got our u and our dv figured out, we also need to figure out what du is, and we also need to figure out what v is. So we can figure out what du is by taking the derivative of u with respect to x. So the derivative of u with respect to x is simply just 1, since the derivative of x with respect to x is 1. And then if we just were to multiply the left and right hand side of this by dx, this would simply become du is equal to dx. We've defined what du is now. So now let's go figure out what v is going to be. So if we were to just integrate the left and the right hand side of this right here, we have the integral of dv is equal to d dx, dx, the integral of d dx dx. And then if we integrate this side, we simply have v. We integrate this one, we have e to the x plus some constant, but we're not going to worry about the constant right now. So this is our v. V is equal to e to the x now. So now we have all the parts we need. So basically this is going to equal u times v. U is equal to x. V is equal to e to the x. So this is our u times v right here. And then we just subtract the integral of v times du. V was e to the x. And du was dx. So this simply becomes x times e to the x minus the integral of e to the x with respect to x, which is simply e dx. And then we can go ahead and add our constant term. So this is our answer now, and we can actually simplify this a little bit. Factor out an e to the x out of these first two terms, so this becomes e to the x times x minus 1. And then that's plus some constant. So we went ahead and just solved the integral of x e to the x with respect to x. And it turns out that it's equal to e to the x multiplied by the quantity of x minus 1 plus some constant. So this is the solution, and we got that by using integration by parts. So I hope this example helped you guys understand how to use integration by parts. I appreciate you guys watching. I hope you have an excellent day, and if you haven't already, don't forget to subscribe.
Alright, so this is the example.
Hey everybody. everybody, this is Paul. In this tutorial I'm going to...
Okay, now we have this example one, evaluate x, ex, dx. So the first step is you need to identify u and dv. So u is equal to x, dv is equal to ex, dx. Why? Because we are using Lia-T. So x is algebra, ex is exponent. So algebra comes first, so it will be u, and dv is equal to ex, dx. Then you need to integrate and differentiate. So u differentiate du is equal to dx, dv is equal to ex, integrate to be ex. So here, v equals to e power of x. You need to differentiate dv. So using the formula, the integration of u dv is equals to uv minus integrate of v du. So it will be equals to ex minus ex plus c. Right? So this is next example. You can see here we have algebra and trigo. So how using the Lia-T? Algebra comes first and trigo comes second. So u is equal to 3x, dv equals to sin x dx. Differentiate 3x to be 3. Integrate sin x to be negative cos x. Using the formula, lastly we will get negative 3x cos x plus 3 sin x plus c. This is using the trigo integration. Right? So same as this one, you have algebra and trigonometric functions. So Lia-T. So u is equals to 2x plus 1, dv equals to cos 4x. This is the same solution. You need to differentiate and integrate. Differentiate u to be du, integrate dv to be d, and then using the formula. Right? So this is evaluate e power of x sine 2x. So e is exponents, sine 2x is trigo. So Lia-T, t. Trigo comes first and then e, exponent. So u is equal to sine 2x, dv equals to ex dx. So differentiate sine 2x to be 2 cos 2x dx. Integrate ex to be ex. Using the formula, ex sine 2x minus 2 ex cos 2x dx here. So next, identify back because we have here 2ex cos 2x. Means we need to find one more integration by parts. So this is exponent, this is trigonometric function. So sama it's the same with identify here, u and dv. So u equals to 2 cos 2x, dv equals to ex because using the Lia-T. So trigo comes first and second is exponential function. So u differentiate, dv integrate using the formula here to be, okay, look at here. So you already solved the first one here, ex sine 2x. So ex sine 2x here, minus, so this one to be bracket, big bracket here, 2ex cos x, this one, 2 cos 2x multiply with ex because of the formula. Formula is uv. So u multiply with v. So 2x cos 2x minus integrate of negative 4 ex sine 2x dx. From where? Here. Negative 4 sine 2x dx. So v du. V is ex, du is negative 4. So you just multiply and combine. So we get here one more integration. So this is, actually you need to use the integration by part one more time. But can you see the same equation for the here? So e power of x sine 2x dx. E power of x sine 2x dx. So you need to expand first, negative, 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 Oh my god. Sorry. Negative, negative. So negative, negative, positive, positive, negative, negative. Yeah, it's true. So this equation, you need to move to the left-hand side to be positive. Okay, 4 and then plus 1 is equals to, so these things. Okay, so 4 plus 1 is equals to 5 equals to this equation. And then lastly, 5, you need to move to the right to be divide. So 1 over 5. Okay? Right. So this is shortcut methods. This method cannot be used for non-repeated and non-repeated. Can be used only for the combination of non-repeated and repeated and repeated and repeated. Okay? So non-repeatable, repeatable. Non-repeatable is NR. Repeatable is R. Repeatable means if you differentiate it, it will be equals to the equation. For example, exponents. E power of x differentiate lagi, you will get e power of x. Trigo, you differentiate sine x, so it will be cos x. Cos x integrate to be, it will be equals to the trigo itself. So non-repeatable is when you have polynomials. Polynomials means when you have 2x differentiate to be 2. So logarithmic and inverse. You need to remember these things. Huh? Okay. So look at this example. Evaluate 2x e 3 power 2x e power of 3x dx. Okay. Sign is positive, negative, positive. You need to begin with positive sign. Okay. So you differentiate. You need to. Oh my god. So this wrong. U is equals to 2x. Here we don't have any x. It's 2x. Okay. So 2x and e power of 3x is here. So differentiate e 2x to be 2. Differentiate 2 to be 0. Integrate e 3x to be 1 over 3 e power of 3x. Integrate more, so we get 1 over 9. And then positive 2x, here is 2x. 2x multiplied with 1 over 3, you will get 2 over 3x e power of 3x minus, it will be sign here, minus 2 over 9 e power of 3x plus c. So this is wrong, yeah? Remember, this is 2x here. Okay. So evaluate e power of 3, x power of 3 multiplied with e power of x. So using the Liate, this is algebra, this is exponents. So algebra comes first, Liate. So x power of 3 differentiate to be 3x squared, differentiate to be 6x, differentiate more to be 6, differentiate to be 0. So e power of x integrate to be e power of x, so all e power of x. So positive x cubed ex here minus, sign here is minus 3x ex plus 6x ex minus 6 ex plus c. Okay.